So hello everyone, welcome to Yourpedia education. Today we are going to discuss our first lecture on microprocessor 8085. So अगर मैं 8085 if I'm talk about the 8085, this is the basic microprocessor which is in the syllabus of, you can say, your graduation. We mostly study this is in graduation. It is the part of gate exam and several exam. It is the part if you are giving any competitive exam. So if I'm talking about the BEL exam, in BEL exam there are several questions from the 8085 that are the basic questions. So you should focus on this subject. I think around 4 to 5 to 6 to 7 questions you can think about that it will come in BEL exam out of 100. And if you are going for BDL, there are also around 5 to 6 questions are from the 8085 microprocessor. So this is the important subject and we will going to cover around 3 lectures. We will cover up completely with the questions here. So today is our first lecture. So we are going to discuss about the 8085 microprocessor. See, basically first thing, what is a microprocessor? See, if you talk about in your computer, there is a one thing that is called as CPU, central processing unit, right? So in your inside your microcomputer and inside your computer there is a unit that is called CPU. That CPU is called as inside that CPU you have a microprocessor. So microprocessor is the central processing unit of your system. So you have to know that thing about the microprocessor. So microprocessor is what? Heart of your computer, right? Without microprocessor your computer will not work. So this is a you can say the microprocessor is your CPU, but currently there are several CPUs. Current generations are higher than this. So it is the basic generation. It is a 8-bit microprocessor. We are discussing everything about 8085 in detail. So this microprocessor is Intel 8085 microprocessor. Before that several microprocessor are come, Intel 400, Intel 800, right? Intel 8082, 8081, like that. So there are several microprocessor, but they are low level microprocessor. So in our syllabus it is Intel 8085 microprocessor. So first thing you have to know about this before going to its structure, that this 8085 microprocessor is 8-bit microprocessor, right? It is using 8-bit data, means you can say if we are talking about the several things here, it is having the 8-bit, you can say, in the form of register, accumulator, and here all the arithmetic and logical operation, everything will be performed on the 8-bit. That's why it is called as 8-bit microprocessor. And this microprocessor is built on NMOS. So which technology it is using? That is NMOS it is using, right? So every microprocessor having its own, like it is built on NMOS. Sometime he may ask you the question that 8085 is built on which technology? CMOS, NMOS, PMOS. So what will be the answer? NMOS. So it is a microprocessor, 8-bit microprocessor which is built on NMOS, right? And this is, see, one more thing, there are several type of IC packaging. So it is using LSI, large scale integration. And whenever we talk about at which voltage it will work at 5 volt DC voltage, right? And if I'm talking about its frequency, at which frequency it will work at a frequency of 3 megahertz, right? It consists of mainly, see, if I'm talking about the CPU, we generally see only one thing, that it is a CPU. This is your CPU, or you can say the microprocessor. But inside that one we have 3 things. The main structure of this microprocessor consists of 3 things. First is arithmetical logical unit. There is one thing that is called as ALU. Inside this microprocessor we have ALU, that is arithmetical logical unit, right? The main function of this arithmetical logical unit is that to perform all type of arithmetical operation and logical operation. Arithmetical operation means addition, subtraction, multiplication. These are the arithmetical operation. Logical operation means you have already studied that thing in your digital electronics. The logical operation is AND, XOR, OR, NOT. These are the logical expression. So if I'm talking about this arithmetical logical unit, so this arithmetical logical unit is responsible for all the arithmetical and logical operation inside your CPU. Then the second term is timing and control. Timing and control is also a unit, the separate unit, timing and control. And the third thing is registers. Registers is one type of memory which is inbuilt inside the microprocessor. We are discussing later on in detail about that, right? So basically first I am going to discuss about timing and control. So this is the structure. We have ALU, arithmetical logical unit, timing and control, then we have the registers here. So first, next thing to second point, that timing and control. See, basically due to this timing and control unit, you can control the flow of data from the microprocessor to the IO device, microprocessor to the memory. It will control the flow of data in both the direction. Either it is going from microprocessor to the input output devices or input output devices to the microprocessor. See, inside your microprocessor, input output devices are like inside your computer. If you see, you have a computer, there is a motherboard. Motherboard is just a processing unit like CPU. So you connect the motherboard with your or you can say your computer with your keyboard. The keyboard is IO device, right? Input output external device. Keyboard, monitor, these are all the things are external device, that is called as IO device. So sometime if you are pressing something from your keyboard, that information will go to your motherboard, or you can say to your CPU. So CPU will control that information. So with the help of these timing and controls, right? The data will be flow from keyboard to the microprocessor. There are two types of input output devices. Some are input devices, some are output. That will depend on that thing. So basically the flow of data will be controlled by the timing and control unit, right? Next thing is the registers. Let us discuss with the registers. So registers are what? Registers are the memory elements. See, basically you already studied, or you may be studied after digital, in the digital electronics you may study there are several type of registers. Registers is a collection of flip-flops. Let us take, we are making a 8-bit register. So 8-bit register having 8 flip-flop, because one flip-flop will only store 1 bit of information. So if you are making a 8-bit register, so how many flip-flops you have required? 8 flip-flops we are requiring. And let us take, there are how many types of register? There are first is one register that is called as accumulator. The first register inside your microprocessor, that is accumulator. What is the use of this accumulator? Basically inside the microprocessor, if I'm talking about this accumulator, whenever you are performing any arithmetical or logical operation, the result of that arithmetic operation will be stored to this accumulator. Remember that thing. The function of the accumulator to store the data or store the result during any arithmetical and logical operation. Second thing, inside your microprocessor there are 6 8-bit general purpose registers. These are the general purpose. There are 6 8-bit general purpose registers. The name of this register B, C, D, E and then HL. So these are the 6 general purpose registers inside your microprocessor. If you are you have to store any information, you are storing any information from your main memory. This is not a main memory, this is the part of, remember that thing, this is the part of microprocessor. The main memory is separate to this one. See, if I'm talking about this one B, C, D, E, HL, so these are the general purpose register. If you have to store, basically let us take you done addition and result is stored in accumulator. Now you are performing the other operation and you need that result after some time. So what we can do, we move this information or we move this result to another register. You can use any one of these registers. These are the 8 register which is available at that time. You can use that as register, you store that information there, then you can perform other operation. If you require that information, you can take back from these registers. So these are the general purpose registers. And there is a 116-bit register, that is the stack pointer, right? Stack pointer, see, basically whenever you are performing you are running a you can say the code inside the microprocessor. So what happens inside the microprocessor, there are several things how this code will be fetching the information and like that, everything. So basically what it will did stack pointer will store the address of the next instruction which should we have to perform after. Let us do, you are adding something, so stack pointer will be storing the next bit, next instruction which we have to perform. The address of that instruction will be stored by this 16-bit stack pointer. And there are 16 programming counter, status register, temporary register, instruction registers. These are the several registers which are also available inside your microprocessor. So I already told you register A hold the operand during the program execution, and there are 6 general purpose register, B, C, D, E and HL. D is missing here, remember that, D, E. D is also here, D and HL. These are the 6 8-bit registers. See, basically with the help of these registers we can make a 16-bit register. If you require a 16-bit register to store the information, so we can make a pair here. So the pair which is valid pair which is available here, that is BC pair, DE pair and HL pair. See, basically this HL pair is used as a memory pointers. We will discuss it later when we are discussing about the instructions of 8085. So this is about the registers. Now if I am going to the pin, not pin diagram, this is the architecture of 8085. See, inside this architecture what we are seeing here, this is the internal data bus. Internal, what is the work of internal data bus or data bus inside of any microprocessor or microcomputer? First let us discuss about this one. Okay. This is the 8-bit internal data bus. What is the use of data bus? Data bus will always take the data and it will flow, means it will provide the data to the microprocessor, or it will taking the data from the microprocessor, store that data to the particular memory. So it is used to flow the data. See, basically this is the serial input, serial output. There are 2 types of pins are there inside this serial inputs, serial IO control. There are SID, SOD. This is the output pin, this is the input pin. If you are input something, that will be done from this pin, and this is the output. If you are giving the output, that will be go here. So if this is the bidirectional, every time remember the data bus is bidirectional, because it will take the, see, basically if you giving the input from this one, so data will flow from the output IO device to this microprocessor, so it will take the data. If you are giving the output to this IO device, then it will go in this direction. So this, sometime he may ask that your data bus is what? That is a bidirectional. Bidirectional means data will flow from any direction from here. It will go either in this direction, either in this direction. It will depend on the situation. So that is the you can say the data bus, the internal 8-bit data bus, which is carrying the data either from the microprocessor to IO or IO to microprocessor inside the microprocessor. So basically that is the use of this one. Next thing is flag register. We are going to discuss about every details about these things, right? Interrupt controls, we have separate lecture on this one. Interrupts and controls. Basically interrupts and control, if you talk about this thing, the basic idea of this one, let us take, you are running your microprocessor, right? You are running your computer. If there is something happen to that, then like any your wire is running, wire is burned and anything, that is called as interrupt. Any type of interrupt we are going to discuss in detail about the interrupts. So any interrupts will come, then what will do your computer? So that is your interrupt control unit. That is there are several type of interrupts which it can stop, that you want to stop your computer, like it is running and you want to stop that program, that is also interrupt. You are providing an interrupt signal that stop this instruction. There are several types of interrupts inside your microprocessor, so we are going to discuss in detail later on. This is your accumulator. So accumulator will store the data, accumulator will back to store that data in these registers. See, whenever you are performing any arithmetical logical operation in this ALU will store the data here, or it will store anywhere the data. So basically the accumulator is what, where you can store the information. So it is also bidirectional. This is the temporary registers, this is the flag flip flop or flag registers. We are going to discuss in detail about this one. Instruction registers, right? Instruction decode, machine cycle kill, encoding, that is the all of the things we are going to discuss. This is your register types. This is the general purpose registers. When you use as a combination, that is become a special type of register. This is your stack pointer, program counter, and incremental decremental address latch. These are the structure. Can you see here? These are all the units which we are going to discuss in detail later on. Okay, let's start. There is a term that is called as stack pointer. Yeah, stack pointer and program counter. Stack pointer see, if I am talking about stack pointer is a special type of register. Stack pointer is a sequence of memory location defined by a program in a LIFO function. LIFO means which one is coming last, that will be going out first. LIFO. So one more question it may arise here, that is a stack pointer. So stack pointer is LIFO. LIFO means least in first out, right? So which information will come at the last, that will be coming out first. So stack pointer is just contain the address of the stack cap. I already discussed this thing. Stack cap, it contain the, see basically what is happening in detail. You will understand that thing with the examples when we discussing about the jump and branching instruction. So basically whenever you are performing any operation, right, you are performing any operation and suddenly you have to jump another location, right? You have to jump another location. The program says that you have to jump from here to the other location. So then what it is doing, it stored that this next instruction is the data it will store in the stack pointer, that whenever I come back, give me this data, give me this one, right, the last one. So basically it jump to the next instruction, it perform that operation, it will back, then it will retrieve that data from the stack pointer, right? That is the use of stack pointer. So whenever you are performing any jump and any instruction, then it will store the location of the program, that I am running this one, store that one here, then go to the next one, and whenever it come back and it will start performing the same operation, then it will retrieve that information from the stack pointer. That is the use of stack pointer, which is in 8085, right? That is the 8085 use of a stack pointer. Then the program counter, the address of the next bit to be executed, that will be stored in program counter. Next one is instruction registers. It holds a copy of current instruction until it will decode. See basically in your 8085 microprocessor, all the informations are stored in the form of, you can say, hexagon code, hexadecimal code. So first we have to decode that code. Until it will decoding, all the information will be available at this instruction register. Next one is status register. See basically inside your microprocessor there are several type of flags. We are going to discuss here status flags in detail, right? How many types of flag? There are 5 types of flag in your 8085. So status register will contain the status of each flag, right? We are going to discuss. So next one is temporary register. Temporary register store the result immediate of the calculation. See, basically we are doing any calculation, and inside that calculation, if we are required to store that information for some time, that will be done in temporary register, right? The next question, the next thing is, what is the status flag? They inside the 8085, if I am talking about the status flag, there are 5 types of flags inside 8085. First flag is carry flag. Carry flag. So here it is detailed. See, whenever you are performing any addition or subtraction, if the carry, this is the 8-bit addition, let us take 1101, like 1101, this is 3, 3, 6, 7 and 8, and you are adding 1, 0, 0, 0, 0, 0, 0, 1. You are adding these two informations, right? These two numbers. So basically it is going to be 0, 0, 0, 0, then 1, then 1, then 1, 0, and this one. So there is a carry from the MSB. So whenever you are getting carry from the MSB, then your carry flag will be set, right? You are performing any arithmetic operation, the addition of two number or subtraction of two number, there will be borrow flag, right? If carry will come out from your MSB result, then your carry flag will be set. Set means it going to be 1 during the arithmetic operation, and otherwise it will be 0. So from this one we can get that there will be a carry from the MSB. That is the thing about the carry flag. Next one is sign flag. Sign flag, if I am talking about in the 8085, it will tell you the status that your result is positive or result is negative. That will be told by the status of this sign flag. If your result will be positive, then it will be set, otherwise it will be, result will be positive, then it will be reset, otherwise it will be set. See, basically in your 8085, all the arithmetic operation is performed in 2's complement form. So whenever you studied in digital you will check that thing, that your MSB, see, if I am writing a number in 1101 like this is in 2's complement form. So this MSB represents the sign of the number, right? If MSB is 1, then result the number is negative. If MSB is 0, then number is positive. So in this one, the sign flag, what the sign flag do? Sign flag check the MSB, right, of your result. If MSB of your result is 1, then it will set, and it says that your result is negative. If MSB is 0, then it will be 0, because you are working in 2's complement form, and it will tell that the number is positive. So that's the meaning of sign flag. Sign flag is which tell you the status that the result is positive or negative. Next thing, if I am talking about the 0 flag, the 0 flag is tell you the result is 0 or result is 1, right? Result is 0 or non-zero. So if your result is 0, then 0 flag will be set. If result is non-zero, set means 1. Remember that thing if I am saying set. Or if result is non-zero, then it will be reset. Next is parity flag. Parity flag, whenever your result, whenever you perform a arithmetical operation, right, your result, either arithmetical or logical operation, on both these flags are set to reset. See, whenever you perform an operation and your result contains the even number of 1, then your parity flag will be set, otherwise it will be reset, right? If even number of 1, then it will become 1. If odd number of 1, then it will become 0. Auxiliary carry. The another flag is auxiliary carry flag. See, there are inside your microprocessor, we perform the 8-bit operation, arithmetic operation, addition. Let us take. It is 1, 0, 0, 0, 0, 1. See, whenever you perform the operation, this is 1, this is 1, this is 0, this is going to be 1, and the carry is going from the 4th bit to the 5th bit, right? 4th bit to the 5th bit. So then your carry flag will be set, otherwise it will be reset, right? Auxiliary carry, regarding auxiliary carry, lower nibble to the upper nibble, right? That is the lower nibble, that is the upper nibble. The lower 4 bit is called as lower nibble and the upper 4 bit is called as upper nibble. program status word. This is the special type of register inside your microprocessor. It is a combination of 8 bit where 5 bit indicates the status of 5 flag, right, and 3 bits are undefined PSW, and the accumulator treated as act as a 16-bit unit. See, basically PSW and accumulator combined become a 16-bit unit. So inside your 16-bit units, status of 5 flag you can check and the result you can check. So from that result and status of flag you can tell that the accurate result is positive, negative, 0 or like that, every information. So that's why this is called as program status word, right? Program status word and accumulator we can treat as a 16-bit unit of stack operation, right? Now that the bus organization of 8085. If I'm talking about the bus organization, see, inside the bus, what is the work of your bus? Bus means which is carrying the information, right? See, basically there are two types of bus. One is address bus, another one is data bus. Data bus, inside your 8085 we have a data bus of 8 bit. And you can say the address bus is 16 bit. So inside your 8085 we have a address bus of 16 bit and data bus of 8 bit. Let us back here the architecture. Okay, see, this is the 8-bit internal data bus, right? Basically the address bus and the data bus we have, if I'm talking about, you can see here this one, this combined become address bus. So address bus contain the address from A0 to A15, and inside this address bus lower 8 bit will work like a data bus also, right? So address bus and data bus are combined in 8085. Whenever you require, you are sending the address, right? You are sending the address, then the all 16-bit work like a address bus, right? Whenever we are sending the data, so what happen? The upper address bus remain goes away. Only this lower 8 bit will work like a data bus. So these are multiplexed together, right? They are combined together. So there is no separate address and data bus. They are multiplexed together. So if you have a 16-bit address bus, which is carrying the address of the memory location, so inside that one lower 8 bit, when you are transferring the data from memory to the microprocessor or microprocessor to the memory, then lower 8 bit will work like a data bus, and the combined from A node to A16 will work like a address bus. So there are a term that is called as address latch enable, which will decide that now we are doing the address fetching or either we are doing the data transfer. That is the use of this one. So come here, back here, the bus organization in 8085 8-bit microprocessor, there is a 8 bit of, that's why we call this 8-bit microprocessor, because here we have a 8-bit data bus, right? 8-bit data bus. 8 bit of data can be transmitted in parallel form or to the microprocessor, right? It will go in the parallel form to the microprocessor. Address bar is 16-bit wide as a memory address of 16-bit. 8 MSB bit address are transmitted by A8 to 860. Means your 8-bit address, MSB 8-bit address will be carried by A8 to A15, and 8 LSB address are transmitted by the data bus. See, I already told you that data bus is combined with the address bus. The address or data bus transmitting the data and address at the different moment. Yeah, that is the main thing. They are not working at the same time, they are working at the different time. When we are transmitting the address, we are only transmitting the address. When we are taking the data, we are only transmitting the data, right? Different moment, and can be transmitted the data or address at a time, right? Can't be sent. This is the symmetric pin diagram of 8085. So we already discussed this thing. You can see here, these are the address line, right? These are the address line, data line, and we combined become address line. This is the clock, this is the hold signal. These are the external, the hold and HILD we are going to discuss. These are the trap, these are the interrupts, right? Interrupt acknowledgement signal we are going to discuss in when we are discussing about the interrupts in 8085. This is the VSS VCC. So what are the values we are going to discuss here? X1 and X2, reset in, reset out, IO and memory out or memory in, S0, S1, all of these things we are going to. This is called address latch enable, ALE. This ALE will decide that your data is going or your address is going to SID, SOD and ready. These are the pin diagram of your 8085. Now we are going to discuss each pin in detail here, right? Each pin in detail. So pin description of 8085 you can see above. So here is A8 to A15. These are the output pins. Can you see here the arrow? Every time each pin have its arrow that shows the data is going from where to where. See, basically in 8085 this is the microprocessor. So if you are connecting one memory and you are sending the address of that memory, so address will be sent by 8085 to that memory, and it will enable that address and take the data from that one, and it will provide to the microprocessor. Or if you are storing the information, it will enable that address and the data will go from microprocessor to that memory location, right? So basically A8 to A15, these are the address bus are used for most significant bit of your memory address or 8 bit of your IO address. If you are doing the IO addressing and you are connecting the IO will be connected 8 bit, that will be used by this one. And A0 to A7, these A0 to A7, these are input as well as output. It means they can take the information or they will carry the information, right? They will take the information from microprocessor to memory or memory to microprocessor. Yeah, these are the bidirectional. They can work in the bidirection. So we can say there are time multiplexing addressed. So these are the time multiplexing addressing with the data bus, right? Here we do the multiplexing, means we combine these two terms together, right? They are servers dual purpose. They are used for the least significant 8 bit of your memory address during the first clock of your machine cycle. Again, they can used for the data bus for the second cycle of your machine cycle, right? Second or third. We are discussing in detail when we are discussing about the instructions. Next one is ALE, arithmetical logical. ALE is address latch enable. That is not arithmetical logical unit. That is called as address latch enable. See, whenever your address latch enable, right, whenever your address latch enable goes high during the first cycle. So whenever your address latch enable goes up, it means it shows that your address will carry by the address bus. It means lower or upper both are working as a address bus here, right? If it is goes low, it means it is working as a data bus. Now IO, input output means IO. It is a status signal. It is only telling you the status. Will distinguish whether the address is for memory or IO. See, basically when you are seeing here, there is a pin that is IO. Yeah, this is the IO pin. So this IO pin will tell you that currently we are dealing with IO device or memory device. If this is 1, then we are dealing with the IO device. If it is 0, then we are dealing with the memory devices. It means memory. So there are two types, the computer memory and the IO. So which one we are dealing, it will depend on this one. It will telling you that we are dealing with IO devices or memory. So that will tell by this pin. So this is the output pin. On this pin we can get that information that we are dealing with the IO devices or the memory. Then S1 and S0, you are seeing that these two pins, S1 and S0, they are telling you the status that which which type of operation we are performing. See, inside the microprocessor, if your S0 and S1 both are 0, it means your microprocessor is in halt state, right? If your S1 and S0 is 0 1, then we are writing, right? We are writing to the memory, right? Next one is 1 0. If this status is 1 0, it means we are reading the memory, right? And if we come 1 1, then we are fetching from the memory, we are fetching the information from the memory. So this is the status code of 8085, which is telling you currently which operation we are performing. We are at the halt operation, we are at the writing, or we are reading, or we are fetching the information. That is the use of this one. RD. It is a signal to control the read operation. When it goes low, the selected memory or IO device is read. So it is generally the output, and it will tell you that if it is low, it means it is 0. When it is 0, then we are selecting the memory or IO device to read. Means we are reading from either from the memory or either from the IO device. And WR are used to control the writing operation. When it is goes low, the data on the data bus is written into the selected, either it is written into the memory device or it is written in the input output devices. So basically these two are responsible for the data flow, that your data is reading or writing. Either we are reading the data from data from the memory or IO devices, that will be told by this one. If it is 0, then we are reading the data from the memory or IO devices. If writing WR is low, then it means we are writing the data onto that memory or IO device. That is the use for this one. Next one is there is another ready pin. So whenever this is the ready pin is the input pin, we are providing the input there. If the ready pin of your microprocessor, right, is low, then if it is low, then microprocessor will go to the wait state until your ready pin will goes up. See, whenever you connect a IO device, right, whenever you connect a IO device to your microprocessor, right, so whenever you connect a IO device, microprocessors don't know that your IO device is ready to perform its operation or not. So it will check the status of this ready pin, always checking the status, checking the status until the status of this ready pin goes 1. Until that one it will wait, right? Then as the ready pin goes up, then it will start communicating with IO devices. So that is the use of this one, right? It is a IO or peripheral devices, we can say, right? Next is hold. Hold is the input pin. It will indicate that another device is requesting for the use of the address or data bus. See, basically inside your microprocessor is performing operation. Then if your hold pin goes up, then microprocessor understand that someone, because there is a CMA, basically you connect, let us take an example, you connect two pen drives to your microprocessor, and your microprocessor understand that, or either you can take that you have a computer memory and you are performing an operation to copy the data from your memory to the pen drive. Let us take this example. So whenever it provide you the path that you have to connect here, so the microprocessor will lose the control of your address and the data bus, so that the complete information will be go from memory to the you can say the pen drive. So there is a unit that is called as CMA, right? We will discuss it later. CMA is responsible for that one. Whenever your computer lose that one, so this hold status indicate that the other device is requesting the address and data bus, right? They are perform their operation, it will lose the it will wait until that hold signal again goes to 0. That is the thing. Whenever your hold signal will remove, the hold acknowledgement signal will be sent it, and it will take control of your address as well as the data bus. That is the main thing of this one, right? HLDA, it is a signal, hold acknowledgement signal. It indicates that the hold request has been received. After the removal of hold request, the SDLA go low, and your CPU will take over your buses half clock cycle after the held goes to low. So it will take control of your IO devices. Then INTR, it is also interrupt, it is also input signal. This is the interrupt request. Amongst the interrupt, it has the lowest priority. See, whenever you are having the interrupt means which is telling your computer or memory side, you have to stop, right? You have to stop. Something is happened, you have to stop. There will be a fire, you have to stop, right? Don't work. This system will fail you. So there are, every interrupt has its own priority, right? We can't do na, like your computer is performing a very important task. We don't want that it should stop. So we provide that that if there is a fire, you should stop immediately. That is having highest priority. According to that one, we will give the priority level to each interrupt. Interrupt, did you understand what is the interrupt? Interrupt means which are interrupting the performance, interrupting the operation of your computer. So we will provide you you can say the priority to each interrupt. So this is INTR. This is an interrupt request signal that your interrupt is coming, but it is having a least priority. So if this interrupt is coming and your computer is performing any important task, then it will ignore this one, right? That is the main thing. The interrupt is used the IO device to transfer the data to the microprocessor without wasting the time, right? But it is having the lowest priority. Like we are providing that we provide the interrupt signal that stop and provide you can perform this operation, you can perform the transfer the data from memory or microprocessor without wasting the time. But if your microprocessor is performing any task which is most important, then a microprocessor will ignore this, or it says that you can wait for some time. First I perform this, then I will do your work. That is the main thing here. Next is INTA. It is an interrupt acknowledgement sent by the microprocessor after the INTR is received. See, whenever your microprocessor receive INTR request that this interrupt is coming, then when your microprocessor free, it will send acknowledgement signal to that one that I receive your request. Now you can take over, you can do your work. That is the interrupt acknowledgement signal. There are several RST 5.5, 6.5, 7.5. These are also the interrupt signal in your 8085. These are called as reset interrupt. We will discuss in later. We are discussing in detail about all the interrupts. So these are the programmable mask. I will teach you that in detail in the next one, right? TRP is the highest priority. Trap is the highest priority interrupt. It is the emergency situation. There are two types of interrupt, that is non-maskable which cannot be ignored, maskable which can be ignored. So this is trap is a non-maskable interrupt, right? It is an emergency situation. Whenever trap will come, either microprocessor doing anything, it will stop immediately. It will not perform that work. So that is the thing. So if I am going for the order of the traps, first is order of the interrupts. The first is trap having highest priority, then RST 7.5, 6.5, 5.5, then INTR, that is having the lowest priority. Okay, when an interrupt is recognized, the next instruction is executed from the fixed location. See, okay, let us discuss one thing. If one interrupt is come, then what should microprocessor do? So every interrupt has its location, and corresponding to that location something is written. Like if your trap interrupt is come, so what should microprocessor do? Trap interrupt is coming at the input pin, it is goes high. So what happened to do that? Microprocessor stop everything and goes to this location. This is a predefined location. On this predefined location something is written that you have to perform this. You have to, sometime it is written you have to stop there. We write that there, that you have to turn off, right? So it at this location what it should perform, it will be written at this location. So these are the fixed locations, right, for every interrupt. Like we have a RST 5.5, then if this interrupt will come and microprocessor will take that interrupt, it will go to this location. At this location we are writing that what should he do, what should it do. That is the thing. RST 5.6.5, these are the locations. So you have to check these are the fixed location for each interrupt, that whenever these interrupts will come, then it will go to this location. That is the main thing here. At this location every information will be available, and there is a subroutine is executed which is called as ISS, that is called interrupt service routine, subroutine, right? Next is reset in. Reset in is an input pin. It requests the program counter to 0, right? It will set that program counter reset to 0, either it is working anything, right? And reset interrupt is enable and the hold HDL to the flip flop. Next is reset out. It indicates that your CPU is being reset. Now it will be reset to its original position. X1, X2, these are the terminal to be connected to the external crystal oscillator that will provide you the frequency. So this, at these two pins X1 and X2, we are providing a external crystal oscillator, right, to provide the operating frequency. Clock, it is a clock output for a user which can be used for other digital uses, integrated circuits. So basically we have a clock pin. You can, if you let us take, if you are connecting a counter with the microprocessor, though that counter will be synchronized to microprocessor. That why we are having a clock pin, so that we can connect this to the counter and counter will communicate to the microprocessor. SID, it is SID is the input pin. It is the data line to serial input. See, if you are doing a serial input, then SID pin you can use, and SOD is the output pin which is used for serial out the data, right? That is the main thing. And this microprocessor will work, I already told you that it will work on DC. Then you have to connect the VCC. At the VCC you have to connect the 5 volt DC supply, and VSS is the grounded for the reference. So these are the all architecture of 8085 which we discussed. In the next class we are discussing about the interrupts, different type of interrupts. Now some questions from these topics which I bring here. That which of the following is the correct about the data bus width of 8085? So in 8085 the data bus is 8 bit. So what will be the answer? B, right? How many address line in 8085? The address line in 8085 are 16 bit. So whenever you have a 16 bit address line, so how many memory location we can generate? Let us discuss this thing. Sometime he may ask you that you have a 2 address line, like 2 address line. So from these 2 address line, how many addresses we can generate? So basically it is 00, both the line will have 00, 01, 10 and 11. Only 4 locations we can generate. So the memory size is how much? 4 bit. Means 4 bit, 4 memory locations, and each location, if we store a 8 bit data, so we can say 8 into 4, that is 32 bit. That is a 32 bit memory. Bit to byte, if you divide this by 8, then you will go, that is a 3 byte memory. So with the 2 address line we can generate only 4 addresses. With 3 lines we can generate 8 addresses. So inside your 8085 we have a 16 address line. So how many addresses you can generate? That will be 2 raised to power 16 if you convert this 2 raised to power 16 into this, that will be 64 kb. So basically the limitation of this 8085, that is, it only, you can connect only a 64 kb memory with that one, right? Not more than that one. That is the main thing, right? The 8085 microprocessor has how many general purpose register? There are 6 general purpose register, that is B, C, D, E and HL, and their combination, we can use that their combination, that is a special purpose register, that is B, C, D, E, HL. The special purpose are separated, but we can, if you required, you can combine this 88-bit register, that is B, C, D, E and HL. What is the function of program counter? So what is the function of program counter? Store the next instruction address. That is the function of program counter. Next is stack pointer. Stack pointer, what is stack pointer? Stack pointer is a 16-bit register that that point out the top of the stack in the memory. It is used to the stack operation like push and hold, that will be done. Push and pop, push and pop. Try to understand one thing. Whenever you have a stack, see, you have a stack, right? Stack is a register which is having 16-bit register. So you put something here. This operation is called as push. We are pushing to the stack. We are pushing information inside the stack. Now, when you are taking out that information, that is called as pop. We will discuss that later. All right. Which control signal is used to difference between memory and I/O? Memory and I/O will be done by I/O and M. This is a M bar. Remember that one, M bar. This is active low signal, right? So that will differentiate that we are performing a memory operation or I/O operation. Which is the role of accumulator in 8085? Perform the arithmetical and logical operation. You already know that thing, right? What is the function of ALE, address latch enable? It will differentiate right, or multiplex your lower address bit, lower 8-bit address bit will multiplex with address or data bus. It will define that one, that currently you are using the lower 8 bit as a data bus or a address bus. That will be the latch is the lower byte, because I already told you 1 byte is equals to what? 8 bit. So he is saying that latch the lower byte of the address. That is the answer. The answer is C. Which flag in the flag register is set when the result of an operation is 0? That is a 0 flag, right? I already discussed this thing with you. What is the function of hold signal in 8085? The hold signal request control the system bus. See, whenever we discussing about the hold signal, it is asking about the control of the system bus, that I can do I can perform this operation, right? And the microprocessor, when microprocessor receive this hold request, then it will send a acknowledgement signal that you can now do that thing what you want whenever your microprocessor is perform the current executing the operation. Which instruction fetch cycle take place in 8085? The machine cycle. Sorry for that one. Right, that is a machine cycle. I am going to discuss that one later, right? Don't worry about this. The width of a flag register in 8085. If I am talking about the flag registers, see, basically there are 5 flags, but the register is 8-bit, right? 3 bits are not used there, right? That is the main thing. So it is 8-bit. Next, what is the maximum clock frequency in 8085? That is a 5 megahertz we can use with 8085. Which of the following instruction is used to load the accumulator with an direct 8-bit value? See, this is the separate question. We will going to discuss it later. That is MVI, right? The next is the 8085 microprocessor follow which of the following type of memory addressing techniques? See, your 8085 will dealing with von Neumann architecture, right? That is the main thing about this. This is the basic information. So this is our first lecture regarding the microprocessor, where we are discussing about the architecture of 8085. So that's it for today. So we will see in the next class. Bye bye.